Hey everyone, welcome back! We're thrilled to have you here with us today. Today let's dive into a topic that's been captivating minds for centuries: perpetual motion machines. These fascinating devices have intrigued scientists, inventors, and dreamers alike. You've probably heard about these hypothetical devices that could, in theory, run forever without any external energy source. Imagine a machine that never stops, never needs refueling, and works indefinitely. Sounds like free energy, right? Well, let's break down why that's not quite the case. The concept is tantalizing, but reality has some strict rules. First off, perpetual motion machines have been a dream for inventors since at least the 12th century. The allure of creating a self-sustaining machine has driven countless attempts and innovations. One of the earliest designs was by Bhaskara II, who came up with a wheel filled with mercury to keep it spinning forever. This ancient Indian mathematician and astronomer was ahead of his time. Fascinating stuff, but ultimately not feasible. Despite the ingenuity, these early designs couldn't overcome the fundamental laws of nature. The real roadblock here is physics. The laws of physics are unyielding and set boundaries that even the most creative minds can't bypass. The first law of thermodynamics tells us that energy can't be created or destroyed, only transformed. This means that any machine needs as much energy put in as it puts out. So, any machine needs as much energy put in as it puts out. There's no way around this fundamental principle. No free lunches in physics, unfortunately. Every action has an equal and opposite reaction, and energy must be accounted for. Then we have the second law of thermodynamics. This law introduces the concept of entropy. This one states that entropy, or disorder, always increases in a closed system. Over time, systems naturally progress towards a state of greater disorder. In simpler terms, any real machine will lose energy to friction, heat, and other forms of dissipation. These losses are inevitable and prevent perpetual motion. That means it will eventually grind to a halt. No matter how well designed, the machine can't escape these energy losses. Let's look at some failed attempts. History is filled with ingenious but ultimately unsuccessful designs. Overbalanced wheels, for instance, use weights or arms trying to create an unending imbalance, but they always find an equilibrium and stop. Despite the clever mechanics, they can't sustain motion indefinitely. Then there's Robert Boyle's self-watering pot from the 17th century, which used capillary action to cycle water endlessly. Boyle was a brilliant scientist, but even his design couldn't defy gravity and capillary limits. Nice try, but gravity and capillary limits spoiled the fun. The pot couldn't maintain a perpetual cycle. Magnetic ramps. They tried to use magnets to keep a ball rolling forever, but magnetic fields weaken over time and the ball stops. The diminishing magnetic force couldn't sustain perpetual motion. So, have we ever made a working perpetual motion machine? Nope. Despite numerous attempts, no one has succeeded, and the laws of physics suggest we never will. These fundamental principles are unbreakable. But don't lose hope. The quest for perpetual motion has taught us a lot about energy, mechanics, and even the universe itself. The journey has been as enlightening as the destination. Who knows? Maybe future discoveries in exotic matter or quantum mechanics could shake things up. The future holds endless possibilities. For now, though, perpetual motion remains an enchanting impossibility. It's a dream that continues to inspire and challenge us. Thanks for watching. If you enjoyed this dive into the world of impossible machines, hit that like button and subscribe for more intriguing explorations. See you next time.